Good morning, everyone. Welcome to DevPulseCon 2020, our first virtual conference. We are honored to host attendees from around the world this year. So I would like to personally welcome those of you who do not speak English as your primary language. So here goes. Please forgive me if I mispronounce things. Namaste, India. Assalamu alaikum to the Middle East, India, Singapore, and Malaysia. Welkom, Netherlands. Shalom, Israel. Hallo na karibu, Africa. Herzlich willkommen, Germany. Ni hao, China. Hola y buenos días, Mexico. And welcome to the United Kingdom, Australia, and New Zealand. And last but not the least, to my fellow North Americans from the USA and Canada, a very hearty and warm welcome. This is a very strange year, as you all know. We had to postpone our conference from the usual April timeline to October due to COVID. It has given us the time and the resources to bring together a fantastic lineup of keynote speakers, workshops on technical and product management topics, as well as panels on being the sole income earner and finding a path from engineering to product management. And to keep everyone from burning out from all the Zoom sessions and online meetings, we have streamlined 2-hour morning and afternoon sessions. All timings for our sessions for DevPulseCon are Pacific time. I wanted to take this opportunity to mention ThriveWise programs we provide to companies as separate standalone programs. We have our innovative Ally training for engineers and PMs, as well as our groundbreaking Safe Space program, which we are currently piloting at a prestigious Silicon Valley tech company in 2020 and 2021. Both of these new programs are in line with our mission to help improve workplace environments so that technical women can thrive in the workplace. So please do take a look at our programs on our website, thrive-wise.org. That is thrive-wise.org. And once again, welcome to DevPulseCon.
Hi, everyone. Good morning, good evening, good afternoon, wherever you are today. My name is Elizabeth K. Joseph, and I'm here to talk to you about open source on the modern mainframe. One of the reasons I wanted to talk about this topic was because when I joined the mainframe community about 1.5 years ago, I thought it was mostly full of proprietary software. And so learning that there was so much open source software on there was really extraordinary for me. Partially because my background is in open source projects. I've been working on them for 20 years. My background's as a Linux systems administrator, so I've been doing Linux sysadmin for that long. And so open source is this common thread throughout my career. A couple of things I wanted to mention. There's lightning talk, so we'll go fast, but the slides will be available if you want to look at them later. So the first question I had when I joined the community was, what exactly is a mainframe? Does it have storage? Does it have processing? Is it just a big computer? And the answer is that it's kind of a big computer, but it focuses on networking, CPU and memory. And so the storage is on a different machine. And inside this big mainframe, it has a processor that is called S390X. That processor is not x86, so it's a different architecture, but it is designed to do a lot of really fast data processing. On a fully loaded system that's like 4 19-inch racks put together. It's got 190 processors, up to 40 terabytes of RAM. These things are super powerful. So my next question, aside from what it is what exactly does it run? So I was super excited to learn that it has run Linux for over 20 years now. Zowe Enterprise Linux was the first Linux to be run on it, like for real, as like a paid offering that still exists today. And it has a ton of open source software that runs on Linux. It does still have some proprietary operating systems, but we're here to talk about open source, right? It also has this open source legacy. When I started reading about the history, there's this organization called Share, and they were founded in 1955. They actually created one of the first operating systems, the Share operating system, in 1959, and that was later adopted by companies and organizations around the world. So Linux, it started as a community port. It was a group of folks who got together and thought it would be really cool to run Linux on the mainframe. That's what people were doing with Linux in the 90s. IBM released their first patches in December of 1999. As I mentioned, Zowe Linux became the first one that's still in production. Red Hat quickly followed. And in 2016, Ubuntu joined. So now there's 3 big Linux distributions that are supporting it. And what I like to tell people is that if you have an application that you're running on Linux, it probably runs on the mainframe. And this is kind of like a vanity slide of a bunch of logos. These are all things that have been built for the architecture. As you can see, the Linux distributions are there. There's also a bunch of community-driven Linux distributions that have ports. And it's not just making it work kind of okay on Linux. Because the mainframe is very specialized hardware, open source actually is able to leverage some of that hardware. So when you're talking about like cryptography and encryption and other things on your Linux machine, the open source tooling can actually hook into that hardware support. So you're able to run all of your crypto stuff on the actual mainframe hardware. Another way things are made easier by running Linux on the mainframe is there's a bunch of Docker images that are built for the architecture. So again, one of these vanity slides of like all these projects who have ported their applications. So they're not just building for x86 anymore. I don't know if you can see my t-shirt. I am wearing the Open Mainframe Project t-shirt. This is a project by the Linux Foundation. And they host code projects that are related to the mainframe. So they provide project hosting, blogs, podcasts, all kinds of stuff that you need if you want to run a project that is specific to the mainframe. They also provide third-party tooling if you want to run your existing open source project on the mainframe. There's also a software discovery tool that was just launched by the Open Mainframe Project. It currently it searches a bunch of Linux distributions to find open source packages if you want to know if the software runs on it. In the next iteration, we're going to add a bunch more stuff. Another tool that's been really interesting from the Open Mainframe Project is called Zowe. This one does hook into the proprietary backends, but Zowe itself is all open source. So if you are using the traditional mainframe operating systems, you have a modern interface to interact with it. So you can use VS Code, you can use a bunch of CI/CD tooling, all this open source stuff in DevOps space. And again, if you have your own open source project and you want to do development, some of the distributions have tools for you. So Ubuntu has Launchpad, and Zowe has the OpenSUSE build service, and these allow you to upload your packages, and then the build service automatically runs them on their mainframes, and then spits back a package to you saying, ta-da, it built. Here's a package that your users can now use. Another thing that you can do is you can get a free virtual machine hosted at Marist College in New York. And this gives you a free, you follow this link from the Open Mainframe Project, you can get a free VM for 120 days running Linux on the mainframe. So you can try out your project with root on a real virtual machine and see how well it runs. Once you know your software runs on the mainframe, you can take advantage of some of the CI/CD tooling that's out there. So Jenkins is an open source CI/CD tool, of course. The Oregon State University Open Source Lab has development hosting on Jenkins. Travis CI also has a build service for open source projects for architecture. So there's S390X and Power and ARM and other ones. So that's all about building and open sourcing your project. But I wanted to take a moment to talk about languages. So when you compile source code for a different architecture, it's pretty much the code is identical. But the compiler or interpreter needs to be built for that architecture. And most of them are for the mainframe these days. C, C++, Node.js, Python, Go, they're all fine. But one thing you may find, so my first suggestion is just try to build your code on the architecture. It's probably gonna run fine. If not, you'll want to dig deeper into the language. So if you're writing something in C, it might not run as well as something written in Python, because Python is a higher level language, so it doesn't have as much interaction with the hardware. But that is where I wanted to conclude. I'm happy to answer any questions. We're going to have some Q&A and later today as well. So feel free to reach out. Thank you, everybody.
Awesome. Thank you, Liz. That was great.
Thanks.
Hello, everyone. My name is Prathyusha Charagondla. I'm a site reliability engineer, and I'm also concurrently pursuing my master's in information and data science at UC Berkeley. And I'm here to talk about algorithmic bias and how we can prevent unfairness in our algorithms. Before I go ahead and get started, I wanted to start by telling you guys a little story. That's right, it's story time. Recently, I was fortunate enough to be on both ends of the hiring table, as both an interviewee and an interviewer, and I can say both are definitely enriching experiences. However, I did find that as an interviewer trying to fill a position with having many other priorities, it's a bit difficult really prioritizing my time to find the best candidate. And this is why a big company actually took on this venture to try to come up with an algorithm that can efficiently and effectively find the best candidates to fill a position. And this sounds like a great story, it sounds like it would have a great ending, but unfortunately, this story did not have a happy ending. What actually ended up happening was that this algorithm ended up biasing against female candidates and favoring male candidates. And to understand the reason why this happened, we really need to go back to the beginning of the story, where it all happened, the data. The data that they were using was the current pool of software engineers at the company, which at the time was predominantly male. And you can definitely see where this is going. Thus, the training data that went into the algorithm had a greater proportion of male resumes compared to female resumes. Thus, in the end, unfortunately, the algorithm ended up favoring masculine language, ended up disadvantaging anytime the women's or women's college or similar words were mentioned in the actual speech, in the actual resume. And so this is actually an example of algorithmic bias, as we can see. If we're not careful with the data and preparing it, this is what can happen. Algorithmic bias, defined, is systematic and repeatable errors in a computer system that creates unfair outcomes. As we saw, unfair could really mean favoring a certain population or community over another, or even disadvantaging a certain community or population over another. As we saw the male applicants or candidates being favored over the female applicants. Now, why does it matter? I gave you one example, which is discrimination in terms of hiring, but there are other real-world examples where we have seen this happening in current day. One specific example is in the case of facial recognition. So Joy, a grad student at MIT Media Lab, found that facial recognition software found it difficult to recognize dark-skinned women. This can be problematic because of the application of this software. These algorithms are currently being used by government agencies, specifically even law enforcement agencies, to detect and identify criminals and fugitives. Can you see where this might be problematic? If we have false positives, what might happen is we are saying that an innocent person is potentially the criminal. This can have unintended consequences and place the burden on the innocents. Additionally, these algorithms that are often being used are not audited for their accuracy, which means that some of the results that we see might not be actually what's intended. But we're still currently using them in production, making it problematic. Now, another example that we've seen lately is in the case of social media monitoring. Schools have been monitoring students' social media to determine which students are at risk and dealing with them as needed. So this means essentially, if I tweet, the school that I'm attending could potentially look at the different tweets I'm posting, and then based on what I've written, potentially make some judgment calls. And this can fall prey to misinterpretations. What if I tweeted something that I did not mean, and the school interpreted in a different way? Well, that means that I could potentially be expelled, or expelled for other reasons. And this is actually what happened to many of the students who may have tweeted accidentally. Now, the second reason why this matters is because there might be potential regulations in this space. We've seen in the privacy space, there have been a lot of regulations from the government on how we handle users' data, whether it's GDPR or the CCPA. We can see that there will be similar regulations in the future, especially as algorithms become more prevalent. And we see that more and more users are using similar, more and more companies are creating similar software and putting these out for the world. So definitely taking these precautions earlier on means that we can save a lot of time and costs by fixing these right now. Next, I'll be talking about how we can prevent this. And really, this is an interesting concept because I think step 0 is really just admitting that there's bias and acknowledging it. There's a concept in tech called techno-chauvinism, where we believe that algorithms are completely infallible, that they're perfect. And I am unfortunate to break it to you, they're not infallible. You know, we as humans are flawed, unfortunately. And when we're making these algorithms, they will conversely, of course, turn out to be flawed at times. But we can prevent it, thankfully. And one way to do so is really start from the data. Understand where the data is coming from. What is the composition of the data? Can we think about anonymizing the data? And what variables are there that could bring about bias? Starting from the data means that we're really understanding the components of our data and really preventing any biases that might come about from there. 2, really think about incorporating in our design. I know we've all heard about privacy by design, but I encourage you to think about fairness or equality by design. What this really means is incorporating equality into the design phase itself, and then thinking about it through the execution, and then finally the evaluation phase. In the execution phase, thinking about what variables in our model might be causing bias, and then in our evaluation phase, really thinking about how we can prevent or mitigate bias by observing the outputs and seeing if that's really what we intend to do. In fact, I would even recommend really audit and regularly audit and monitor your algorithm. Make sure that is really what you're hoping your algorithm is doing. Have a second set of eyes, maybe from a sister team, to look it over. 3, create an ethical framework. What this really means is come up with some sort of guidelines, really do's and don'ts, telling your engineers or developers what you can or can't do when you're building software. So the European Union recently came out with guidelines for trustworthy AI that's in the space of respecting human autonomy, prevention of harm, and 2 other areas. Having these guidelines in place is very important. Finally, diversity in teams. It's a very overlooked concept, but more diversity means more ideas and more skills. It can increase innovation. It's a good counter to groupthink, and we can find bias earlier in the cycle, which in the long term is very, very helpful, especially because we're having all these ideas come in. Now, I wanted to say, as data stewards, we're responsible for taking the first step. We're here to try to revolutionize the world, build software, and this is our chance to do it the right way, in a fair and equal manner. Thank you.
Great. Thank you, Prathyusha.
Thank you.
This is Srinjita here, and I am a graduate student, a PhD student at the University of Colorado Boulder. So I'm going to present my talk on supporting spatial thinking skills in youth or in students through an augmented reality app called 3D AR Visualizer. So all the 2 talks that you heard about is more industry focused, but here I'm talking more about research and how it ties to K through 12 education Um, so, are my slides forwarding? Yeah. So 3D modeling or 3D printing technologies are being used increasingly in K through 12 education, but students struggle to use these technologies effectively because students they often, what they do is they create 3D models and they just download them from online repositories instead of like creating them by themselves. And they don't feel comfortable using the technologies because often this leads to 3D print failures. So particularly in this talk, I will focus on a solution to this problem. First, what is the problem? So why is 3D modeling difficult? And by 3D modeling, I mean CAD or computer aided design. And if most of you might know that CAD is nothing but a sequence of 2D screen. And it requires one to have good spatial thinking skills to create 3D models and manipulate different shapes in the 3D environment. So I mentioned about spatial thinking skills. So what is spatial thinking skills? Well, it is a form of mental activity which kind of makes it possible to create different spatial images and manipulate them while solving different practical and theoretical problems. And a lot of research is being done which shows that spatial thinking skills is important for success in STEM careers and even in our day-to-day lives. So for example, when we are navigating Google Maps, or even when we are controlling remote operated cars, or when we pack a truck when moving things, one needs to have good spatial thinking skills. And this skill improves with practice and training. And there's a need to train spatial thinking skills from an early age. So for example, from middle school and high school, that's the age group I'm focusing on. So we need to train in this particular skill for a better STEM career and also to be able to perform daily activities more smoothly. So what are some of the challenges when it actually comes to training the spatial thinking skills through CAD tools or the computer aided design tools? So first, with CAD, it involves mental rotation and perspective changing, as you can see in this image here. So this is a model of a house that a student created. And as you can see, it looks perfectly fine from the front view. But when the student is looking at it from different perspectives, they are rotating at it from different angles, they see that there are errors with the 3D model, which they don't intuitively see in a CAD screen because it is a sequence of 2D screens. So this brings us to the next challenge, which is about failed and non-functional prints. So when students are not able to create error-free models, they often get frustrated because the print fails and they are not able to succeed with the outcome that they intended to. So thus, the benefits of learning 3D modeling and utilizing 3D printing technologies as rapid prototyping tools, they are not being leveraged as it should be. So there is a need to practice debugging. There's a need to practice debugging 3D models to allow for better understanding of the 3D space. So this not only benefits students, but also other novices in general and helps train their spatial thinking skills. So to aid in this debugging process, I have used augmented reality. So I created an AR or augmented reality app called 3D AR Visualizer. So in this app, students can upload their 3D models and test them for any errors like gaps, alignment issues, and so on, which they wouldn't be able to see intuitively otherwise. So next I will play a video of a student testing their 3D model. So they will be uploading, they generally upload the 3D model to the app and use a marker, as can be seen in the image here, to test the 3D model. So here is the video of the student looking at the 3D model. So here they're rotating the 3D model from different perspectives. They can zoom in and zoom out. This is a chess piece that they're trying to test. The student says, oh my gosh, there are so many gaps in the 3D model because the shapes are stacked on top of each other. So there are a lot of gaps which they don't realize in a CAD environment. So then they realize that this wouldn't print because the shapes are not aligned properly. So not only this one student, there were other students who mentioned that I was able to see many open spaces in my chess pieces and also other 3D models that students tested. So this app, the 3D Air Visualizer, was useful in testing for gaps, different alignment problems, and understanding overall 3D models better. We were able to test this particular app in different settings. So about 350 students in both in middle schools and high schools have used this app. And this app is part of a curriculum, and as part of the curriculum, the teachers are implementing 3D printing to make it more approachable or easy to understand for students, and in the process enhance their spatial thinking skills. So we have collected data in different forms and conducted different surveys. And from our findings, we do want to conclude that augmented reality can definitely help identify defects in 3D models, and it can provide scaffolds for youth to learn 3D modeling and create successful 3D prints. And finally, from my research, I would like to suggest that 3D modeling and AR or augmented reality together, it should be used to enhance spatial thinking skills. So here at the bottom of the screen, on the right side, you might see a link. That's the link to the augmented reality app that I've created, and that's being used by students. Even right now, we are in the phase of data collection. And with this, I would like to conclude my talk. And if we have time, I don't know, we want to open up for questions. You can follow me on Twitter or reach out to me via my email if you want to know more about my research. With that, thank you so much.
Great. Thank you, Srinjita.
I'm gonna stop my screen share if I can find myself.
Yeah, if you can stop your screen share. And we have Prathyusha and Liz. Can you please start your video? Awesome.
Hello.
And Srinjita, can you start your video and stop your screen share?
Yeah, so this start video.
There we go.
There you go. Perfect.
So we have a few minutes. Thank you all for your talk. Let me just see. Cool. So I'm going to ask a few questions from the audience and some that we had prepared earlier. So let's start with you, Liz. One of the questions we had is, how do I get involved with the Open Mainframe project?
Right, so that's pretty easy. They have a page where they list, so you go to you can do a Google search for the Open Mainframe project, but it's a Linux Foundation page. They have lists of projects. They have lists of how you can join their Slack, how you can join the mailing lists. So pretty much what I suggest is go and explore the page and then join the resources that you're interested in, because they have all kinds of projects spanning Linux and other operating systems and other things. And always feel free to reach out to me. I'm always happy to help anyone who's interested.
Can you share your Twitter handle?
It's, at P-Leia2, like Leia, Princess Leia, so P-Leia2, the number.
Cool, thank you. Next question is for Prathyusha. So one of the questions is, what can we do if our data is biased?
Yeah, that's a good question, actually. I think one of the things is really understanding where the bias is coming from, like whether is this the variables or is this coming from the actual data source. And once you kind of narrow down where the bias is from there, what you can do is really try to reframe the question. That would be my next source of my next advice. Really reframe the question to see, is there another way that I can use this data potentially? Because really sometimes, unfortunately, biased data just means that you may have to scrap it, because it's best to really come up with a solid algorithm. We have to take those steps rather than coming up with something that has that's using biased data and ends up being biased in the long term. Mm-hmm.
Cool, thank you. I have a question for Srinjita.
Sure.
How are you measuring the change in students' spatial thinking skills?
Yeah, that's a great question. So I think I kind of touched on it, but not really. So it's about, we have these different measures that have been tested a lot in research about spatial thinking skills. So we look at pre and post in the intervention. So pre at the start, even before they start using any CAD tools or learn about things, and see where they are. They have a score, and then look at it after. So we compare the two scores, and that's how we see that if they things have improved or not. And that's how we measure the change in spatial thinking skills.
Okay, thank you. Back to you, Liz. You mentioned Docker. If my software is already being built into a Docker image, does that mean I can just use it as is on the mainframe?
That is a great question, and one that people trip up on all the time. So the short answer is no, because it is a different architecture. The good news is you can take your existing Docker file that you use to create that image and just run it on an S390X machine. So maybe the free VM you get from Marist College, or wherever you want to build it, and build the Docker image there. And then once you have the Docker image that's built on the correct architecture, then you can run it on it. But you can use the same Docker image pretty much, or the Docker file. So that's good.
Cool, thank you. Prathyusha, should algorithms be regulated? What sort of regulations should be set in place?
That's a great question. And this is a bit subjective. I definitely believe that algorithms should be regulated. We've definitely seen what happens when we don't regulate algorithms. We tend to see algorithms that are biased, have negative consequences. And the real problem is, the burden tends to fall on the users, unfortunately, and not so much the makers of the algorithm. So yes, they should be regulated. And definitely, I think this is a tricky area, because if we're not careful, we can also be stifling innovation. But I really think if we're careful in terms of, setting ethical bounds of, what we can or can't do, like, documenting the data, being transparent about some of the processes. If we're really careful about the way we set it and really clever, I think there is a way that we can definitely regulate them. Mm-hmm.
Cool, thank you. Final question for Srinjita. What are some of the limitations of the app right now? What do you think can be possible extensions for your app?
Mm-hmm. That's a great question. Right now, it, like I mentioned, mostly it looks at alignment issues and gaps and those kind of things. So not so much about the scale. So some of the things that students themselves have suggested, oh, this would be really cool. So they were like, can you actually show how the CAD or the 3D model is in a real life? So that is something that the tool is missing right now. So it gives a scaled down version. So it's like a placeholder for the 3D model, but it's not like an actual scale. So if it's like 10 millimeters, does it actually scale to 10 millimeters on the app? Does it show it's super big or super small? Because if students don't understand the scales, then the print can be very big, or it would not print the way it's supposed to. So that's a limitation. And the extension would be, we want to add it like a Chrome extension, so that the workflow or the user flow is more intuitive, rather than them having to go to a separate app and link to it and download. And so making it easier for students, because that's the user base that I'm focusing on right now.
Right. Awesome. Thank you all for your talks and for the Q&A session. I do want to mention that at 10:45 to 11:15, we are having a meet and greet with all our panelists. So please do join us at that time, and you can directly ask them questions yourself in that session. So with that, this session is a wrap. We will be back in a few minutes with our keynote speaker, Minosha Cherian. Thank you all. Minosha Cherian is a principal engineer in the Design Reliability Organization at SpaceX. Most recently, she was responsible for defining fatigue and fracture methodology for reusable rockets and getting the process implemented across the company. Prior to SpaceX, she held a variety of roles at Honeywell Engines related to structural analysis and methods. She has a bachelor's from the Indian Institute of Technology and a master's in aerospace engineering from Stanford University. Please welcome Minosha Cherian. And I wanted to mention, due to policies instituted by SpaceX, we will not be recording this keynote session. So I am going to stop the recording, but please do tune in to hear Minosha's talk. So I am stopping and pausing the recording.